kitchen. And she is a software developer from ThoughtWorks. She teleported here from Sydney, Australia. She is Charlie Gerard!
Am I supposed to? Thanks for that. Good afternoon, everybody. So I know it's the end of the day, so hopefully you're not too tired. So before I start, I was told that it's always good to have a slide to introduce yourself. The thing is, I'm really bad at this, so here you go. That's me. That's pretty much as good as it's going to be. So I'm a dev, and I am DevDevCharlie on Twitter if you want to send any comments or questions anytime. And I have the slides live if you want to have a look at it. I didn't know exactly the setup of the room or how big the screens would be. It looks pretty big, but in case you can't see at the back, it's right there. Also, I'll share them on Twitter later if you want to have a look. So I'm going to start really simple with stuff that you probably know what that is. It's a computer and it's a phone. And personally, I think that it's a bit of a restrictive way of interacting with interfaces and accessing the internet. Like, we've adapted to the technology that we built instead of trying to build technology that was adapting to us. So what I like to do on my personal time that has nothing to do with what I do on my job is to explore alternative way of interacting with things. And what I would like you to do for the next half an hour is to not be skeptical about the things I'm going to say, and to try to just follow me in imagining how it would be to interact with interfaces and the internet in another way than what you are used to using. So what are interactive technologies anyway? So I just listed a few, and to start with, we have wearables, and some of you might already been using or wearing some. You might have a Fitbit or smartwatch or anything, and these devices allow you to just walk around and they track your steps or your heartbeat or something, and you don't have to think about it. It kind of does the work without you having to think, and then you can check the interface later on to see how many steps you did or stuff like that. I actually don't have one, so I don't know, but I imagine that's how it works. Then you have voice. Some of you might have a Google Home or Amazon Alexa. And same, you're able to walk freely in a space, and you don't have to be in front of the computer or holding a phone. You can just give a certain command and get your information freely. So it's a bit of a better step towards being able to access things the way you want to access them. Then you have motion. Some of you might be working in offices where when you step into a room, the lights turn on, and you don't have to think about it. You don't have to think about turning them off, because if there's nobody in the office after a certain amount of time, it just turns off. And that's really cool as well. Facial recognition is a bit newer. For example, when I was going through security at the Sydney airport, you just scan your passport, and then they just scan your face, and if it matches, you can go. You don't interact with people, you don't queue. It's super fast, and it's one of the how they use facial recognition. You can also now unlock your phone with your face. I find that a bit creepy, but you can do it. Some of you probably have that phone. And finally, you can use biofeedback. And what I mean by that is using devices to track how your body as a system is going, and then use that data. And more specifically, what I'm going to talk about today is this brain sensor that's called the Emotive Epoch that I've been working with for the past couple of years. But before I go and talk about how the actual device works, I thought I would talk about how the brain works. So I'm not a neuroscientist, so I'm going to try and keep it really simple, because also the purpose of that talk is to show you that if you want to get started with this, it doesn't have to be hard, and you don't have to know the really hard scientific terms. So to start with, you have a brain. So that's a good start. And this brain is made of a lot of neurons, and these neurons are specified cells that just process information. But it's not just a bunch of neurons that are randomly placed. Your brain actually has different parts. By the way, this slide is going to look horrible, because it's very hard to find icons of brain that actually look nice. So I had to put just pictures together. And there's a lot of text as well, because I didn't know how to put that information. But anyway, so the brain has different parts, and each part is responsible for different functions. For example, if you want to move around, the part of the brain that is responsible for movement is the cerebellum. I don't know if I'm saying it properly, but that's that thing. And it's responsible for motor functions. And what's happening is that you have basically cells in your motor cortex that send their axons, this part of like a neuron, down to your spinal cord, and then it connects to the motor neurons that activate the muscles. So basically, your entire body is just connected and feeds it back to the brain. So why am I talking about that anyway? So the reason why it's important to know that is because when you think about EEG and how to track brainwaves, the fact that the brain has different parts responsible for different functions is actually important because this is called the 1020 International EEG System, which basically shows you where electrodes have to be placed on the head and what they're actually tracking. So they have some kind of like reference number, and they track different stuff. And the ones highlighted in green and orange are actually the ones used in the emotive epoch. So it has a different system because it has only 14 electrodes rather than a lot more in some kind of like more technical medical devices. And here, well, you have the device where you can see where the electrodes are. But what is really cool is that as a JavaScript developer, you can actually use that now in JavaScript. So for the past couple of years, I've been building a framework. So it took me 2 years because it has like C++ in the background, and I don't have a C++ background. And it was quite actually hard for me to understand how it worked. But anyway, so now you can do it in JavaScript. So what does it do? You don't actually have to buy the sensor to start playing with this, because you can download an emulator that's called the Emo Composer, and it kind of fakes that the headset is placed on your head properly, and you can send different actions. And so yeah, you can do that without having, because to set up the device, you have to put some gel, and it can take a bit of time, and also to carry, it's a bit fragile, so you have to be careful. So if you don't want to carry it around, you can still use the SDKs and stuff like that using this composer. We also have access to live data. When I'm talking about live data, I'm not talking about raw data, but I'll talk about that a bit later. So first of all, you have access to the gyroscope and the accelerometer that are part of the device. So when the device moves around, you can have access to the X and Y data of how the device is moving. So you can do stuff with just moving your head. Then you have performance metrics, that your amount of focus, excitement, attention, boredom even. So you can get that data. You also have access to facial expressions, so you can know when you're smiling or blinking or looking right and looking left and stuff like that. And finally, you also have access to some mental comments. And the way that works is that it's predefined, so you have to download their software. There's a list of maybe about 10 comments that you can train. And you select the one that you want to train, and you start the training process for 8 seconds, and you try to really focus on that thought especially. And the data is saved in a file, and it's basically using machine learning in the background. It's not open source, so you don't actually know what kind of algorithm they're using and what kind of classifier they're building. But it's basically building a machine learning model that you can then reuse in your applications to classify live data. So the tech stack behind that. So when I bought the sensor, I didn't actually check if there was any JavaScript thing. So when I got the device, I actually was like, oh shit, there was just like C++ and Java SDK, and I don't have that kind of background at all. But I wanted to be able to build something in JavaScript. So I used the C++ SDK, and I built on top of it what we call Node.js add-on. So this is like the 3 modules that are used there, Node-GIP, Node bindings, and NaN, are the old way of doing Node.js add-on. Now you can use NAPI, but I have not had enough time to update it. And I think actually somebody sent me a pull request. I think he updated it, but I didn't check. So for now, it's using that. But later on, if I get the time to check the pull request, then it might be updated to the new way of doing things. So that would be cool. OK, so that always comes too fast. I'm not ready for this. So, OK, before I go on, I thought I would show you what it does. But before, I need to tell you that sometimes it doesn't work. A lot of the times it doesn't work. I tried it this morning, and I realized I didn't have enough gel, so it didn't work properly. And then I had to go to the pharmacy, so I have gel now, so it should work. But even then, there's a lot of times when it doesn't work. So bear with me. Also, you have to remember, like, it's tracking my brainwaves, so there's a lot of chance that this setup is not quite great to do that. So to start with, brain keyboard. So that's the first thing that I built. That does not use the mental commands. That uses the facial actions. So what I did was just, I wanted to be able to communicate with the movement of my eyes. So I just built this really quick prototype of a keyboard, and if I look right and left, I should be able to go from letter to letter. And when I blink, I should be able to actually select the letter and write with it. But first, I need to set up the sensor. So I did put gel on the stuff before, so it would be kind of ready. But I feel like there's never enough gel, so I'm going to make a mess a bit, but I will clean it before I go. Yeah, because the thing is, it's a bit annoying, and if I don't do it properly, I'll have to take it off and then put it back on, and that's not great, because that takes a lot of time. I'm putting shit everywhere. OK, so also, I have to plug that in. OK. I'm going to have to exit. OK, I'm going to put that on my head. So it is off for now. Yeah, it's not very glamorous neither. So I think there's enough gel, because I can, yeah. All right. Ooh, sorry. All right, so I don't want to see what I look like right now. OK, so if I turn it on, the USB, yes, OK, so I'm connected. And let me just launch the control panel so you can see if the electrodes are connected properly, if it's launching. OK. Oh, it's not too bad. Oh, I'm losing one here. Oh, hey, hello. Oh, bye. OK, wait, let me quit and come back. That's going very well already. Oh, what are you doing? All right. Please, 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 please. No, no, no. OK, wait, on and off. Off and on, that's way better. Why? You know, where? Yeah, OK. I'm going to try. Oh, the thing is, it's behind my head, so I don't know if it's off or on now. Ah! OK, so if I do that, and it should work. I think it's just I fucked up. OK, OK. Ooh, all right, OK. I didn't even do anything. Oh, all right. Oh, no, why you do that? OK, so I'm not sure. No, why? You. Come on. All right, I'm going to quit, and so I won't see if it works or not. OK, so. Yes. No. OK. So if I blink, no. OK. Mm-hmm. Yes. OK. Right. Right. Fucking go right. No. I wanted to write something in Swedish. No, not this one. Oh. I wanted to write hello. Oh. No. Really? Are you for real? Oh. What? Okay. Oh, OK. Wait. Yeah, I kind of wrote it. Oh my God. It's like a very long hey. So that's it. Hello. OK, so that was it for this one. Let me just, oh, yeah, whatever. OK, so, but then, next. So I have a backup GIF because there's a lot of chance that this is not going to work because even the facial expressions have some issues. So what this one is doing is I just wanted to see if I could use the mental commands to navigate a 3D space. I tried to write, build a very horrible futuristic UI, but this is not what matters. What matters is can I move the stuff with my head? As you can see here, I was alone in a very tiny room, so it was OK because that's all I could think about. But this setup is quite different. So let's see if it works. Oh, console log. So before we start, I'm going to tell you what I'm trying to do, because I always forget. And then I'm excited because it works, and nobody knows why I'm excited. So I'm going to try to think left and then think right. So you should go left and then go right. I have no idea if this is going to work. Oh, no, exit. Ah! Bye. No? Hello? All right, so I'm going to have to shut up for a bit. Motherfucker. All right, let me try again. I'm going to kill it. Yeah, I don't care looking right. All right. I did change that demo this morning. That can also be the reason why it's not working. I need to focus. All right, work. No, oh, not this one. What is that? What? This is not the right... Oh, well, OK. Not really... Oh, yeah, OK, wait. Can I think right now? Not exactly what I wanted, but you'll never know. Now I told you, but... OK, I'll try it a third time, just because I don't want to take too much time. Yeah, well... Stop it! Ah! All right. No, it's, well, now I look stupid. OK. Come on, you can do this. All right, so. OK, all the time. Yes! Whoa! Sorry, I was just like, woo! Oh, my God. OK, well. Next. OK, and another demo that I finished this morning that I tried to show before, but it never worked, is using a drone. So I was thinking about using the mental comments for this one, but as you can see, it's not great. So I decided to try with the facial expression. So I'm going to try to just look left, and it should like take off and go further and then land. The thing is, I'm not quite sure how far further it's going to go. So yeah, if you're on the front row, or the few front rows, if it lands on you, it's OK. There's a big chance that it is going to land on you. So the way you stop it is either you get out of your chair, or it has a motion sensor at the bottom. So if it comes towards you, you can just like do that. It's going to try to land, and it's going to see your surface, and it's going to land on your hand. Wouldn't that be beautiful? I'm sure it's not going to be like that. I think, OK, so I need Bluetooth. OK, Bluetooth is on. Also, sometimes I try to make it go forward, and it went backward. So I'm not actually sure which way it's going to go. OK, so it's trying to pair. The noise of it sounds scary, but it's just a toy. Remember that. OK. I should look. OK, it's. It has to connect to. OK. I need to look left. Come on. You can do this. That was just a. Why should I? All right, you know what? Don't look at the code. But yeah, don't look at the code. Is that, what am I doing? This is a prototype. Let me just, yeah, looking left. That's what I did. All right, OK, let me try again. Let me just, I'm just going to see, yeah, so in the stuff that you can launch, you also have a weird face that you can check is working. Oh, hello. I clicked on a button. Yeah, look at that. Yeah, see? All right, let me try again. Just connect. No, I did left. I did left. Yes. Woo! Where is it? Oh, I didn't really go far. I didn't kill anybody! All right. All right, I'm gonna take that off now. Oh my god, yeah. Okay, so code samples. I hesitated to show that because as I built it with the old way of doing a node add-on, I don't know if it's really useful. But just to go, I'm going to go very quickly because I have other stuff to say and I don't know. OK, thank you. All right, so if we start kind of like reverse engineer how it works. So if you start at the bottom, using the nan module, you kind of say, I want to create a node module. And the first argument is the name of your module. Don't call it module because yeah, I don't know why I did that. But the second parameter is the name of the function that it's going to call. And then you have your init function. That, again, terrible C++. But if you don't know C++, then this is beautiful C++. So you kind of say, I want to create a new instance of a function that I call connect to Emo Composer. And it's going to call the function connect here, that is right here. And inside, I use the methods that are available in the SDK. So you start by creating a handler for the state of the emotive data. And then you have different methods that you can call to check if in the state there is a blink or a looking right or looking left and stuff like that. And it just gives you back an integer 0 or 1. And then I just create an event object, and I say when the state is updated, just send that back to me in JavaScript. So then you have a binding.git file where you just say the target name, which is the name of module that I told you not to use. And then the sources is our functions.cc file that was just previously. You just build that. And in JavaScript, you can require that modules using bindings. And then you have access to the functions that you wrote in C++, but in JavaScript. That was a terrible explanation. But it's another way of doing it anyway. So if you want to build a Node.js add-on, I would advise you to just check out an API. It's probably better. I haven't had the time to check it, so I don't actually know how it works. But basically, then when you run your JavaScript file, you have access to the event object with blink in this example, but you can have whatever you want. Limits. So there are some limits, obviously. The first one is that it needs training for each user. Not for the facial expressions, they're quite common for everybody. But to train the thoughts of pushing and pulling and stuff like that, you do need to train. And in a way, it's normal. You would expect it to have to be trained. The way let's say we have the same brain in terms of structure, but in terms of signals sent by the neurons, like the data that you get is different for everybody. You can't track everything. So first of all, the emotive epoch is not open source, so you only have access to the 10 mental comments that they give you access to. But also the fact that we are still trying to understand how the brain works. So some thoughts of actions might be easier to train, or even directions, because they are, I think it's, I don't remember the name of the part, but you have it's like from the top of the brain, these parts here are actually managing the spatial navigation. So this is how you can think about left and right, and you can train that. But also the fact that I think if you wanted to think about a beer or the plane or whatever, this is too abstract to be able to be trained right now. There's a bit of latency, and that I think is something that's going to just be fixed quite quickly. I think there is latency because when you create a machine learning model and you use live data to classify, there is just a bit of time between the fact that when you get the data and when the classifier can tell you if it's pushing or pulling or whatever. But that, with the way machine learning is going, it's just going to get a lot better at classifying your thoughts. And then there is one that's called temporal versus spatial resolution. This is just more to do with the types of tracking the brainwaves. So EEG with sensor like that, it's really good at temporal resolution because you get the data really fast, but it's terrible at spatial resolution because you only have a certain number of electrodes around the head, and it's not really with 14, it can't really track the real activity of your brain all around. But if you look at methods like fMRI scanners, like the big things that you lay down on, they have awesome spatial resolution because you have a view of the entire brain, but they have terrible temporal resolution because you get the data not as fast as an EEG sensor. And also, fMRI is about checking the blood flow in the brain and not really the electrical activity. So it's a bit of a different stuff. But all of these methods are actually getting a lot better now. But you also have opportunities. So the first one that I think about is accessibility, of course. like being able to let people communicate in ways where they don't have to move or to produce sound or whatever is something that is great. Even if my brain keyboard didn't work really well, I still was able to write some kind of word, and you can buy that online. Like, you don't have to go to the hospital and have really expensive systems. You can actually use that. And as a personal story that I never shared because I didn't really want to, but I think it's actually important. 6 years ago, I wasn't a dev yet, but so my grandfather, before he passed away, he got really sick, and he ended up in a state where he couldn't move at all. So before I went to Australia the first time, we were talking and stuff like that, and then 6 months later, he was just totally not the same at all. Like, the only thing he could do is move his eyes. He was still there, but he was just totally not able to move. And sometimes I'm thinking, if I had known how to do that 6 years ago, I would have used it, even if it's not working properly. It's still a way he would have been able to talk to me, and I would have been able to talk to him just by something I can buy online, which is pretty amazing. And then second, mental health. So you could actually see what's happening in the brain when you have conditions like anxiety or depression, and you could see the impact of some treatments on the activity of the brain, and you can see if they're successful or not, and this is something that's really interesting and important. And finally, and probably the most useless, art. But I'm talking about it because usually I try to create useless stuff because it's my way of learning. Sometimes I can't think about a great idea or something useful, but using art or just useless stuff allows you to still explore things that you wouldn't have access to otherwise when you're at work and you're just building forums, for example. So there is something that I try to convince people about, is like useless is not worthless. I think I'm trying to convince you, but I'm also trying to convince me, because I spend a lot of my time building stuff like that, and I've had comments like, oh, you're wasting your time, no one's going to use it, but it doesn't matter. Like, I have learned so much from doing that stuff that, to me, that's the value, and I'm not building it for you anyway. I'm not talking about you, I'll talk to the other people. So next, what's next? So recently, actually a few days ago, just before I flew here, I bought this one here. So it's called the OpenBCI, and it's a brain sensor that is open source. So you have access to the raw data. So it means you have access to the data from each of the 16 different sensors around the head. And the thing is, well, what is cool is that then you can use that data and use machine learning to make your own models and track your own things. The bad thing is that as it's raw data, you have to do the pre-processing and signal processing yourself. And I don't know anything about that. So that's a great learning opportunity, but it also means that it will probably take me a while. And one of the really awesome stuff that I want to build with it is this. So this is called image reconstruction. And on the left, you have a video feed that someone wearing a brain sensor is looking at, and you record the data from the brain. And on the right, you have the reconstruction of that image from the brainwaves. And that is so you can see it's blurry, it's not great. But when you think this is now, you imagine in 10 years, it's going to be a lot better as machine learning systems get better and as devices get better. And you can think about, imagine if you could visualize your dreams, while you sleep and you wake up and you see an actual feed of what you just dreamed about. Maybe it's not useful, but it's amazing. And you can think about ways of communicating. I'm watching something and you can see it from, I don't know, the other side of the world or something. And that is, to me, that is truly amazing. But yeah, again, a lot of machine learning stuff to learn to be able to get there. But it's just incredible. What about you? All right, so what I wanted to say with that is that the reason why I'm giving this talk is that I get really excited about that stuff, and I would love if you experienced that same excitement. So you don't get a car, but what you get is that if you want to get started with brain sensors, you have some cheaper ones and some kind of easier to get started with that are still pretty good. If you want to talk about that later, I can talk a bit more about these ones. But most importantly as well is that if you want to do biosensing and check out biofeedback, you don't have to start with brain sensors. You can also start with just components that you use with an Arduino, and all of it is available in JavaScript. And this is a lot cheaper. Like for less than 50 euros, you could probably have like a heart sensor with an Arduino, and you get that data and you do whatever you want with it. So the kind of sensors that you can get is you can get a heart sensor, you can get gyroscopes, so you can check your movements. You have fingerprint sensors if you want to do something with this. You even have an alcohol sensor if you want to do some stuff when you're drunk. And you. Like this is like even muscle sensors, so you can like stick electrodes on your body and check the data that you get from flexing your muscles, and you can do stuff with that. You have flex sensors, you can do stuff with the movements of your hands, and you had people building gloves to translate sign language just by using that. But all of these are using sensors as inputs, but you can also use them as outputs. And this is where it's going to go. Like, maybe this will never happen, but I saw it in a TED talk, so, you know. So it's using sensors. So when you think about it, your body is basically full of sensors. Like, you know, your brain is just a brain, but what it gets is data from the eyes and the ears and your fingers and stuff, and it gets all that data and makes sense of it. So you're basically, made of sensors and connected to a central system. But what if you could add a sense then? You know, what if you could have a jacket that vibrates and you would understand, you would make sense of that vibration? What if you were, for example, I don't know, instead of having to hear speech, you could feel it. You could make sense of it by understanding the vibration on a jacket. I'm pretty sure that there's already jackets that vibrate to tell you the direction in which you should go, connected to Google Maps or something. But that would be pretty amazing. You have animals that sense the magnetic fields of the Earth. And what if you could just add a few sensors? You don't need to be implanted anything, but what if you just added, sensors on your body, and you could feel how the room is feeling just by having to interpret these vibrations on your body. And when you think about it, yes, you're like, oh, I don't want to learn a new sense, but when you were not born knowing how to interact on a keyboard, you were not born knowing how to swipe on a phone. You learned that because you had to. And when you think about Morse code, people had to learn to write it, but they also had to learn to understand it. And I sometimes would like to know, it would be quite cool if we could enhance our human experience by forgetting about the screen and just thinking about sensing things a different way. And yes, as I said, all of this is not even expensive, and all of it can be done in JavaScript, so all of you can do it. I'm almost done. Resources, I just have a few links. I am definitely not the only one doing stuff with brain sensors. So you have a few different modules that you can try. They're available for different sensors. And some useful links if you just want to check out how to do a Node.js, a Node add-on. And there's also a community called NeurotechX that has a Slack channel, and they have a website with a lot of resources if you want to learn more about how the brain works and how to build brain-computer interfaces. So that was it for my talk. I hope I didn't get too far. Now you can become skeptical again if you want to. But if you want to talk about this, I will be there tonight and tomorrow. I do talk too much about it, so maybe you will regret asking me questions. But maybe do it on Twitter then, because I can't write that much. But yeah, so I'll be there. Hopefully you did learn something, and thank you so much for listening.